Hello friends, welcome to our educational channel Alpha Science Academy. Today again we are going to discuss a very important question, and that is, what is a phonon? Its answer is very informative. Let's start. So what is a phonon? A phonon is a collective oscillation of several atoms. Yes, when a number of atoms collectively oscillate, they produce a phonon. In condensed matter physics, a phonon is a unit of vibrational energy that in fact arises from oscillating atoms within a crystal lattice. Now, what is a crystal lattice? It is a periodic three-dimensional regular arrangement of atoms. A phonon is not a real particle just like electron, proton or neutron, but it behaves like a particle, as well as they do not carry any spin, but they can exist even in vacuum. Types of phonon. In real solids, there are two types of phonons. Number one, acoustic phonon. Number two, optical phonon. Acoustic phonons are associated with long wavelength vibrations where neighbored particles oscillate nearly in phase. That means two things are to be remembered here. Number one, they have long wavelength vibrations. Number two, their neighbored particles oscillate in phase. Here, heat or sound is used to generate such phonons, and they have relatively low frequencies because their wavelengths are high and they fall in gigahertz region. Optical phonons. Optical phonons are associated with vibrations where neighbored particles oscillate nearly in antiphase. That is, optical phonons are out of phase movements of the atoms in the lattice. One atom moving to the left and its neighbor to the right. And this occurs only if the lattice basis consists of two or more atoms. Light is used to generate such phonon. Properties of phonon. Phonons are not real particles, as said earlier, so they are said to have a kind of negative mass and thus negative gravity. A group of physicists at Columbia University is making waves with a new theory about phonons, and they have suggested that phonon might have negative mass and thus a negative gravity. Irrespective of ordinary particles, phonon travel faster in denser medium, and that is an astonishing discovery. As well as they could also be deflected, and due to additive oscillation, they don't satisfy Pauli exclusion principle. Now, what is Pauli exclusion principle? It is that no two electrons can have the same set of quantum numbers. Just like in 1s and 2s, for two shells we have given three examples. The first one is correct and the second and third are incorrect, because for 2s both of the electrons have spin up, and in third example in 2s both of electrons have spin down, and that is against Pauli exclusion principle. So they are bosons. And what are bosons? Bosons are the particles or particle-like things which satisfy Bose statistics. These are some other examples of Pauli exclusion principles for oxygen, fluorine and neon, where 1s, 2s and 2p shells are explained. Some other properties of phonons are that the study of phonons is an important part of condensed matter physics. They play a major role in many of the physical properties of condensed matter systems, such as thermal conductivity and electrical conductivity, as well as they are playing a very fundamental role in models of neutron scattering and related effects. Working of a phonon. A famous scientist, Chen, has said that the bonds between individual atoms in a crystal behave essentially like a spring. That is, when one of the atoms gets pushed or pulled, It sets off a wave, that is a phonon, that travels through the crystal. It is just like sitting down on one edge of a trampoline can set off vibrations through the entire surface. Photon versus phonon. A photon is a form of energy, but the phonon is a mode of oscillation that occurs in lattice structures. A photon can be considered as a wave or a particle, just like in wave-particle duality, which are physically observable entities. On the other hand, a phonon is a mode of vibration which is neither a wave nor a particle. That's it for today. Thank you very much for watching. Goodbye.